you will get the Cayley-Hamilton theorem. Okay. So in examination, compulsory Cayley-Hamilton theorem, they will ask for 10 marks question. Okay, state and prove the Cayley-Hamilton theorem you will get. And the verification of the Cayley-Hamilton theorem, also it will be asked. It is also the 10 marks question, but compulsory you will get the statement and proof and also problems based on this one. Okay. So if you see the proof, first we have to write it as, suppose A is a square matrix of order n by n. So the equation, we know that the determinant of A minus lambda I equals to 0 is called characteristic equation of A. Okay. Okay, now we'll take the matrix A as A11. We know that how we'll represent that one. A11, A12, so on, A1n, and second one is A21, A22 up till A2n, and the last element is here AN1, AN2, so on up till AN. So this is the nth element, and when you find for the A, that is determinant of that one, A minus lambda I. So we know that the diagonal elements, we have to do the subtraction of lambda. So it will be A11 minus lambda, A22 minus lambda, and the last one will be ANN minus lambda. Okay. When you find the determinant of this A minus lambda I, you will get one polynomial like this. Okay. So we are finding this one for nth order. So for the nth order, you will get the polynomial as like this. So why? Because we know that when we find the determinant of a matrix, you will get alternative values. That is, one will be the positive value, another one will be the negative, positive, negative. So that's why we are taking here it as -1 to the power of n, lambda to the power of n plus A1 into lambda to the power of n minus 1 plus A2 into lambda to the power of n minus 2, so on. And the last you will get the constant element. Okay. So when you do the determinant of this one, you will get this polynomial. And you see here, whatever the nth order is there, that degree you will get as the first element. Okay. So each element of, so for solving this one, the thing is just in place of this one, if you substitute capital A, and if the determinant is equals to 0, then the characteristic equation, whatever you are getting here, it satisfies the square matrix. Okay. So square matrix, when you substitute in place of your A1, A2, so on, if you substitute capital A, and if you get the value equals to 0, then the square matrix satisfies its characteristic equation. Okay. So that only proof we have to show. So here, to show this one, we use the, if you have idea, adjoint of a matrix will be there. So if in matrices, when you have studied A inverse is there, no? For finding the A inverse, we'll use A inverse equals to adjoint of a matrix A by determinant of matrix A. Okay. Adjoint of a matrix means for all whatever the here, if it is a 3 by 3 matrix, if you take like this any matrix. Okay. So for each and every element of the matrix, here 9 elements are there. So for 9 elements, we'll find the minors. So 9 minors you will get. The minors will be of the form 2 by 2 order. So you will get 9 different elements, and if you put them in one matrix, which is called as a B, if you do the transpose of that matrix, then it is called as an adjoint of a matrix. Okay. So already in intermediate and also in even in 10th also, you have the concept of inverse of a matrix. So there you have the concept of adjoint of a matrix. So with the help of the minors of the matrix, we'll find the quotient matrix. The quotient matrix, if you do the transpose of the quotient matrix, it is called as a adjoint of a matrix. So to find the determinant of this one, we'll use the concept of adjoint of a matrix. So that's why we are writing here adjoint of A minus lambda I is a polynomial in lambda of degree n minus 1 or less. Okay. So adjoint of A minus lambda I. So whatever this is their equation, when you find each and every element cofactors of that one, then you will get the another polynomial which will be in the form of like this: b naught lambda to the power of n minus 1 plus b1 lambda to the power of n minus 1. So why we are getting here n and here n minus 1 means here lambda to the power of n means whatever the degree you have in the given matrix, that will be there. Whenever you find adjacent of a matrix, you are taking out each row and each column, then you are finding the 2 by 2 matrix. That means if it is a 3 by 3, you are getting 2 by 2. So it is n minus 1. That's why we are starting writing n minus 1. Okay. Plus b1 lambda n minus 2, so on b n minus 1. Okay. So to solve this one, we'll use the concept of, so we have one small rule is there, that is a into adjacent of a is equals to determinant of a into identity element. Okay. So by this, a into adjacent of a equals to determinant of a into I is the identity element here. So with the concept, instead of a, we are substituting here a minus lambda I. So a minus lambda I into adjacent of a minus lambda I equals to determinant of a minus lambda I into I. Okay. So if you want, you can write here that one, that is a into equals to determinant of a into I. So I hope so. So in the down part, you are able to see a. So your last one is a minus lambda I. Last one is a minus lambda I adjacent of a minus lambda I equals to determinant of a minus lambda I into I. Okay. So this we got from the concept of a into adjacent of a equals to determinant of a into I. Okay. So same like this only, if you write in the examination, they will give the full marks. Okay. So only this is the procedure or else the proof of the given theorem. So now here we know that what is a minus lambda I. So the determinant of a minus lambda I means whatever you have, same polynomial you have to write, and adjacent of a minus lambda I means this one. When you multiply these two and when you equate with determinant of a minus lambda I into I, so all cancellation will be there, all the terms will be cancelled and it will be equal to 0. So that only is called as a, where every square matrix is satisfying its characteristic equation. So in your textbook, somewhat different is their proof. So if you write this also, it is the same concept you have. Okay. So here a minus lambda I into adjacent of a minus lambda I, this value is b naught lambda to the power of n minus 1 plus b1 lambda to the power of n minus 2 plus b2 lambda to the power of n minus 3, so on up to bn minus 1. Okay, this is equals to, if you want, you can write here, minus 1 to the power of n lambda to the power of n plus a1 lambda to the power of n minus 1 plus a2 lambda to the power of n minus 2, so on up till an into I. Okay. That is the identity element we have. So here you multiply this a into this one and also minus lambda into this one, and you equate it to this part, right hand side and left hand side. After multiplying this, whatever the left hand side, the elements are there, you equate, that is the same powers will be there, no like powers. If you compare the like powers on both sides, okay, here you can write comparing the coefficients of on both sides. So we'll get like this. It is minus 1 into b naught equals to minus 1 to the power of n. And after that a b naught minus b1 minus 1 to the power of n a1i. Next a b1 equals to minus 1 to the power of n a2. So how you will get these? Because see b naught lambda to the power of n minus 1 into a into b naught. First see. So constant term we have. Last one is there, a into b naught lambda to the power of n minus 1. Here for what we have a1 into lambda to the power of n minus 1. That's why minus 1 to the power of n a1 into I. We have I know there. So here I is. Next we have a into b1 lambda to the power of n minus 1. So to get easy all these terms, first you multiply a into this one, then you multiply minus lambda into this one. So if you multiply these two, what will happen? B naught into lambda to the power of n minus 1, and here 1 is there. So both will get cancelled, lambda to the power of n you will get. So that's why first term is minus 1 to the power of, that is minus b naught. This both will get cancelled, lambda will be there. So this lambda, when you equate here, wherever the lambda term is there, that if you equate only minus 1 to the power of n, I you will get. That is only the constant term. Okay. This is the lambda to the power of n. Here also lambda to the power of n. The quotient of this one is just minus 1 to the power of n into I, and here minus lambda into this if you multiply. So to understand this one, just you multiply this both with this one, then it will be easy. So if you write that one, it will take more time. That's why I am not writing that one. So while writing in the examination, you expand that one and then compare the terms on both sides. So you will get the so on like these terms. And at last you will get AB minus, this is the constant term. It is equals to minus 1 to the power of n an. Okay, you can put them as like this 1, 2, 3, and this is the nth equation. Okay, so when you add, when you multiply them with a to the power of n, first term, then a to the power of n minus 1, then a to the power of n minus 2, and so on up till a to the power of n. If you multiply these all, whatever the equations you are getting with them, and when you add them, if you see here a b naught is there minus b1. Okay, next when you add, you are adding, multiplying with a, no. So here a you are multiplying a to the power of n minus 1, a to the power of n minus 2, so on up till a to the power of n. So when you multiply with this, you will get the same terms, then you can cancel those terms. Here if you add a, you will get ab1. This is plus ab1. Both will get cancelled. Next here ab2. Here next term you will get ab2. So both will get cancelled. So like that, whatever the terms you are getting, that all will cancel and this part will be equal to 0. Only the remaining will be only this part. Okay. So here you can write for these terms here, pre-multiplying the above equations by a power n minus 1, a power n minus 2, so on up till I, and adding them. Okay, and adding them we get, see first a to the power of n b naught. Okay, minus 1 is there, minus 1 here. So that means minus a to the power of n b naught. Here you will get a to the power of n, and next one is a into b naught. So we will get it as a to the power of n minus 1 b naught. So both the terms, like terms, both will be getting cancelled. So this, whatever the left hand side terms are there, all those will become 0. So we will get it as 0 is equals to minus 1 to the power of n. Only this part is left, no? So minus 1 to the power of n is common for all. If you take out common, first term will be a to the power of n. Next you will get a to the power of n minus 1. Next, so a to the power of n plus a1 into a to the power of n minus 1, a2, a to the power of n minus 2, so on. Last will be ani. Okay. So when you will take out minus common, you will get a to the power of n plus a1, a to the power of n minus 1, an I. So this is the whatever the characteristic equation we got starting now, that is a determinant of a minus lambda I. There instead of a we have lambda. So here when you do all this process, you will get instead of lambda we will get the capital A. What is capital A? Capital A is the square matrix. So that means this capital A, whenever we are doing the adjacent of a matrix and we are solving this one, we are getting this equation. If this is equals to 0 means it is satisfying the characteristic equation. So the square matrix A, wherever you are getting, that square matrix is satisfying its characteristic equation. This is a method to prove the Cayley-Hamilton theorem. Okay. So some you may get some theory parts in between. So main concept is this one. So first thing is, first you have to write what is the square matrix capital A. After writing the square matrix, you have to find a minus lambda I. So determinant of a minus lambda I, you will get some polynomial. So with the help of that polynomial, we are finding the adjacent of that determinant. So adjacent of a minus lambda I. So that value is equals to, in terms of b naught, you will get b naught into lambda n minus 1 plus b1 lambda n minus 2, so on like that. So we have one concept is there, that is a into adjacent of a equals to determinant of a into I. With that rule, we are here taking a minus lambda I with the help of adjacent of the matrix, it is equals to determinant of a minus lambda I into I. So when you expand this one, you are comparing the same like terms on both sides, then you will get like these equations. So with the, whatever the equations, you are multiply them with the matrix a to the power of n and a to the power of n minus 1, a to the power of n minus 2, so on up till I, and adding them, whatever the left hand side values are there, those all will become 0. Only right hand side values will be there. So whatever the right hand side values are there, those are the characteristic equation of a square matrix. Okay. So it is equals to 0 means it is satisfying the characteristic equation. Okay. So if you write this proof and statement in your examination, it's enough. Okay. You can score 10 marks. So we'll see one problem. So problem will be verification of the Cayley-Hamilton theorem only. They may ask in 3 different ways. Okay. So one question, one problem will be, they'll ask that verify the Cayley-Hamilton theorem. Okay. Verification of the Cayley-Hamilton theorem is, if you just whatever the characteristic equation you are getting, if you equate that to 0, characteristic equation, if you equate that to 0 means if you substitute the matrix A in that, and if you solve that one, if you are getting all 0, 0, 0, matrix, if it is a 3 by 3 order means 3 by 3 0 you will get. Okay. So then it is only just that verification of Cayley-Hamilton theorem. And second one is, so they'll ask verify the Cayley-Hamilton theorem and also find A inverse. Okay. So in that only question, same verification you have to do and you have to find the A inverse. And third one will be, they'll ask only to find the characteristic equation. Okay. So 3 different ways. The question, same question they will be asking in 3 different ways. So that is the 10 marks question you will get. So if you know one thing, how to verify the Cayley-Hamilton theorem, from that only you will get the characteristic equation. From that only you will get what is A inverse. Okay. We'll see one problem on that one. So the question will be verify the Cayley-Hamilton theorem and find A inverse. find inverse of A, like this different questions will be there. Okay, so the given matrix is here. A is 1 4 5 0 minus 1 0 0 2 0. Okay, this is our matrix A. So first we need to find the characteristic equation, that is A minus lambda I. So A minus lambda I equals to 1 minus, we know that only the diagonal part will be the subtraction of the lambda. Okay, so 1 minus lambda 4 5 0 minus 1 minus lambda 0 0 2, here you will get 0 minus lambda. Okay, so this is our whatever the determinant you are finding of that A minus lambda I. Okay, when you do the determinant of this one, I hope you know how to find the determinant. So when you eliminate the column and also first row and first column, and if you cross multiply this one, see here, only you will get only one value. This is 0. When you eliminate this one and this one, 0 into 0, and last one when you eliminate this into this is 0. So only first row, first element you will get the value. Okay, so A minus lambda value is 1 minus lambda into 1 minus lambda into minus lambda. Okay, this whatever the equation you are getting, okay, this you will get it as lambda cube minus lambda equals to 0. Okay, so when you multiply this whole thing, you will get it as lambda cube minus lambda equals to 0 here. So for this one, here lambda, whatever you are getting, that is only two terms are there, cube is there and lambda. So if you substitute in place of lambda A, that is A cube minus A equals to 0. So this is our characteristic equation. And we know that from here you will get A cube value is A. Okay, A cube value is A. Means whatever A is there, A cube value is also A. When you substitute in this one, what will happen? A minus A is 0. So it is satisfying the characteristic equation here. So for finding the A inverse, we need to find the adjacent of a matrix and that one. Okay, so this is the problem. It is in this, it is very simple one. Just when you will do the A minus lambda A determinant, you are getting here one equation, simple equation we are getting. So lambda cube minus lambda equals to 0. If both, when you split this one, you will get it, that is lambda cube equals to lambda. So cube value and this value both are same. So A minus A means what you will get? 0. So it is satisfying the characteristic equation of this one. Okay, so in this only one more problem you see. So next one is 1 4 minus 3 0 3 0 0 2 minus 1. So whatever we have done last problem, that is will be asked only for verifying the Cayley-Hamilton theorem. Okay, so for finding the A inverse, we can take this one here, that is 1 minus lambda 4 minus 3 0 3 minus lambda 0 0 2 1 minus lambda. Okay, so this whatever value is there, this is you will get it as lambda cube minus 3 lambda square minus lambda plus 3. So this is equals to 0. So when you do the multiplication of this 1 minus 1 into 3 minus lambda and you simplify this, this is the equation. Okay, lambda cube minus 3 lambda square minus lambda plus 3 equals to 0. Okay, you can write the characteristic equation is this one, that is lambda cube minus 3 lambda square minus lambda plus 3 equals to 0. Okay, so now instead of this one, in place of lambda you substitute A value. So then you will get the matrices as So now we verify that. Now we verify that a cube minus 3, in place of lambda we are writing a. So minus a plus 3 equals to 0. Okay. A cube minus 3a square minus a plus 3 equals to 0. First, to verify the Cayley-Hamilton theorem, so we have to find a cube value and also a square value. A is already, it is there. Okay. So for that we need a cube. So a cube is equals to, that is the matrix of this one. So I hope so. First we will find a square. A square means 1, 4, minus 3, 0, 3, 0, 0, 2, minus 1 into 1, 4, minus 3, 0, 3, 0, 0, 2, minus 1. Okay. A into A. So what is the concept of the Cayley-Hamilton theorem? If we are substituting in place of lambda matrix A, if that value is equal to 0, then the square matrix is satisfying its characteristic equation. Okay. So I hope so you know how to find the product of two matrices. The number of columns in the first matrix should be equal to number of rows in the second matrix. Then only we can do the multiplication or product of two matrices. So when you do the multiplication of this one, this whatever the first row is there, first column, first row, second column, first row, third column, next second row, first column, next second column, next third column. Similarly, third row, first column, second column, third column. Okay. Directly I am writing the answers here. So a square value will get it as 110 0 0 9 0 0 4 1. Okay. So this is our a square. Next we need a cube value. That is a cube is equals to a square into a. So this you will get with a square is 110 0 0 9 0 0 4 1, and next you multiply with 1 4 minus 3 0 3 0 0 2 minus 1. Okay. See, 1 into 1 is 1. All other terms are 0. Next 1 into 4, 10 into 3, 30. Next this is 0. So you will get first 1, 34 minus 3, 0, 27, 0. Next 0, 14. Okay. So this is our a cube value. So if you substitute this a cube and also a square and a value plus 3, you will get it. You have to get it as equation is equals to 0. Okay. So minus a, here when you will write, you will get it as I. 3i equals to 0. So if you substitute here, so what is our characteristic equation? A cube minus 3a square minus a plus 3i. So it is equals to, first a cube is 134 minus 3 0 27 0 0 14 minus 1 minus 3 into a square 110 0 0 9 0 0 4 1. This is our 3a square minus a. So what is our a? 1 4 minus 3 0 3 0 0 2 plus 3 I know, plus 3i means 3 into identity matrix. So like this you have to substitute the values. So when you simplify this, So it is equals to adding the corresponding elements of the different matrices. So 1 here minus 3, or else if you get any doubt you can write like this 27 0 0 14 minus 1. So minus 3 ones are 3 3 30 0 0 27 0 0 4 3s are 12 3 minus 1 4 minus 3 0 3 0 0 2 minus 1 next plus 3 0 0 0 3 0 0 0. Okay, now we add the corresponding elements of this one. So it is equals to 1 minus 3 minus 1, last one is plus 3. Next 34 minus 30 minus 4, this is plus 0. Next minus 3 minus 0 minus into minus plus 3 plus 0 0 0 0 0, all terms we have it as 0. Next to 27 minus 27, here minus 3 and that one is plus 3, and this term is also all zeros are there, so 0. Next this is also 0. Next 14 minus 12, here minus 2, that is 0. Next minus 1 minus 3 minus into minus plus 1 plus 3. Okay, here see minus 3 3 minus 1 1 34, here also sorry, here minus, okay, both 34. Next minus 3 plus 3, this is 0 27 27 minus 3 minus 3, and here 14, this is 14 minus 1 plus 1 minus 3 plus 3. Okay, all are getting answer, so you will get it as 0 0 0 0 0 0 0 0 0. So the matrix is of 3 by 3 orders, therefore we are getting the 0 matrix as 3 by 3. So the characteristic equation whatever it is there, this value is equals to 0. So the square matrix A is satisfying its the characteristic equation. So this is the first part. So in some problems they will ask only this one, that is verify the Cayley-Hamilton theorem. So up till here it's enough. So here you can write that hence the matrix satisfies, hence the matrix A satisfies its characteristic equation. Okay, so this is the first part. Next we need to find the A inverse. So for finding the A inverse, whatever the characteristic equation is there, so that characteristic equation you will, if you multiply it with A inverse, then you will get the A inverse value here. Okay, so what we got, the characteristic equation, it is A cube minus 3A square minus A plus 3I equals to 0. Okay, so now inverse of this one means A inverse of A cube minus 3A square minus A plus 3I equals to 0. Okay, so when you multiply this A inverse, this one 1 1, whatever the degree is there, it will decrease. So A square minus 3A minus A square into A, you will get it as I, plus this you will get 3A inverse equals to 0. So we need A inverse, no? A square minus 3A minus I equals to minus 3A inverse. So we need A inverse value. So A inverse is equals to 1 by 3 of A square minus. So negative term is there, no? Or else you put here like this minus a square minus 3a minus I. Okay. So whatever the value you're getting here, a square minus 3a minus I, that value if you divide with minus 1 by 2, then it is called as a inverse. So for this we need a square minus 3a minus I. So what was our a square value? 110, 0, 090, 04 1 and minus 3a, minus 3 into a. Our a was 14 minus 3, 030, 02 minus 1 minus I, in the sense 100, 010, 001. Okay, when you simplify this, so when you simplify this, you will get it as 1 minus 3 minus 1, next 10 minus 12. You are able to see now 10 minus 12, this is 0. Next value is 0, minus into minus is plus 3. Okay, 0, this is 0, that is 0, this value is 0. 9 minus 9. Next is 0, this is 0 and that is also 0. Next is 0, 0, this value is also 0. Next 4 minus 6. Okay, here with 3 you are multiplying now, minus 3 to the 6 and this value is 0. Next last term 1, minus into minus plus 3 and here minus 1. Equals to 1 and minus will get cancelled, only minus 3, 10 minus 12 means minus 2, 3, 0, 0, 0. Next we will get 0 minus 2. 1, 1 will get cancelled, it is 3. Here 1 we have to go. Okay. Here see middle term 9 minus 9, here minus 1 is there. Okay, we have followed that one. So it is minus 1. So 3, 2, minus 1, 10, minus 12, 0. Next what we have? This is 9, no? Minus into minus plus 9. Okay, it's better if you multiply them, then you add, you will get easy. Okay, so minus 3, minus 2, 9, 0, minus 1, 0, 0, minus 2, 3. Okay, so this is the whatever the value of a square minus 3a minus lambda. Now a inverse is equals to, so minus 1 by 3 into this value, that is minus 3 minus 2 9 0 minus 1 0 0 minus 2 3. Okay, you can keep like this only, or else if you simplify this you will get it as minus 1 by 3 into minus 3 minus 2 into minus 1 by 3, 9 into minus 1 by 3. This is 0 you will get, this is minus 1 into minus 1 by 3. This is 0, this is also 0. Minus into minus is plus 2 by 3. Next minus 1 you will get. So place is not there, that's why I am writing like that. Okay. Now when you simplify this, so if you have time, you can simplify this, or else you put like that only. So 3, 3 and here minus into minus plus. So this will be 2 by 3. And this is minus 3. Okay, 3, 3 times. So it is 0. Minus into minus is plus 1 by 3. 0, 0, 2 by 3 minus 1. So this is the answer of the A inverse. So A inverse is equals to minus 1 by 3 A square of this one. So directly you can keep like this, or you just multiply with minus and you keep like that only. If you simplify also it's enough. Or if you are unable to simplify this one, just stop here and you write A inverse equals to 1 by 3 into that one. Okay. So this is a method how to find the verification of the Cayley-Hamilton theorem. Okay. So in this only three types I have told now. First one is finding only verifying the Cayley-Hamilton theorem is only this whatever the equation is there. If you equate it to 0, if you are getting all zeros, then the characteristic equation is verified. And second one is only he will ask to write the characteristic equation. That means A minus delta A. When you find the determinant of that one and when you substitute A, it is only called as a characteristic equation. So third question is they will ask A inverse. So for finding the A inverse, whatever the characteristic equation you are getting, if you multiply that with A inverse, you will get the A inverse value. So from the given this one only, we can find A. Actually, if you see in matrices, they will ask the, if you know the method, matrix inversion method will be there. So in that, we'll find, before I have told no, A inverse equals to adjacent of A by determinant of A. So to find that one, lengthy process will be there. No, we have to find the coefficient matrix. That coefficient matrix, if you'll find the transpose of that one, then you will get the whatever the matrix is there, that is called as the adjacent matrix. So if you find the determinant of this matrix, you'll get some value. If you divide that one, then you'll get the A inverse. So that is another method, and this is the, so by two methods you'll get the same one only, same answer you will get. Okay. So this is about the Cayley-Hamilton theorem. Okay. So try to practice all of you Cayley-Hamilton theorem. So these are only problems asked in 9th unit. So whatever the 10 marks questions are there, you practice some model examination questions also. So in that he has asked the Cayley-Hamilton theorem verifications, and also some 2 by 2 matrix is also given. So 2 by 2 matrix also same method, A minus lambda I, whatever the equation you are getting, in that equation in place of lambda, if you substitute the A value capital A, if it is equals to 0, 0, then it is satisfies the Cayley-Hamilton theorem. Okay. So if you see one 2 by 2 matrix, see like this in your ME model examination questions, they are asked that is A is equals to 2 minus 1, 3, 0. So for this A minus lambda I means that is 2 minus lambda minus 1, 3, 0 minus lambda. When you do the simplification of this one, you will get the matrix as minus 2 lambda plus lambda square plus 3 equals to 0. That is lambda square minus 2 lambda I plus 3 equals to 0. The characteristic equation is lambda square. That is in place of lambda, you have to substitute A. So A square minus 2A plus 3I equals to 0. This is the characteristic equation. Okay. So when you find A value is there, no, A square value will get it as 1 minus 2, 6 minus 3. Okay. So A square we have and A we have. If you substitute in this characteristic equation, A square minus 2A plus 3A is there. So A square is 1 minus 2, 6 minus 3 minus 2A. That means 2 into A. 2 to the 4 minus 2. This is 6. This is 0 plus 3I. Plus 3I means 3 into identity element 0, 0, 3, 0. So 1 minus 4 plus 3 minus 2 minus into minus plus 2 plus 0, 6 minus 6 plus 0. Next minus 3 plus 3. So you are getting this as 0, 0, 0. So it is the 0 matrix we are getting. Okay, so whenever 2 by 2 matrix is also given or else 3 by 3 matrix is given, the procedure is the same one. So if you see here the characteristic equation from this, if you find A inverse, that is A inverse of A square minus 2A plus 3A equals to 0, you will get A minus I plus 3A inverse equals to 0. So A minus I is equals to minus 3 A inverse. Okay. So A inverse is equals to minus 1 by 3 of A minus A. So this is minus 1 by 3 A minus identity element. Okay. Okay, 2 is there. Clearly I am not written right. So minus 2I is also 2I. So A is our given matrix. 2 minus 1 3 0 minus 2I means 2 0 0 2. So you will get it as minus 1 by 3. If you simplify that, 0 1 2 minus 2 0. Here it is minus 1 3 minus 0 3. Next 0 minus 2. So if you do with the 1 minus 1 by 3, it is 1 by 3 plus 1 minus 3. Or you can divide it with 1 by 3. Okay. So like this, for 2 by 2 matrix also we can verify the Cayley-Hamilton theorem. So they may ask even 2 by 2, 3 by 3. So same procedure, first take the matrix A, then find the determinant of that one. Then if you do the cross multiplication, then you will get the characteristic equation of that one, substitute in place of lambda A, then verify that one. If you get all zeros, then the Cayley-Hamilton theorem is verified. So from that, when you multiply the characteristic equation with A inverse, you will get the inverse of the matrix A. Okay, so by this we are completing the block 3. So in block 3 we have seen the 3 units, and even I have told the important questions of 10 marks and 5 marks. Okay. So next we'll go to the 4th block. It is of the quadratic forms. Okay, 4th block is the quadratic forms. So quadratic forms, first whatever the 10th unit is there, it is also the somewhat related to the matrices only. Quadratic forms and inner product space. So here in block 4, whatever the 10 marks questions are there, those 10 marks questions you will get from the inner product spaces. That is the last 2 units are there. No, 10th unit you have the quadratic forms. 11th and 12th unit you have the 11th one is you have inner product space, and 12th one you have Gram-Schmidt orthogonalization process is there. No, based on that. So in inner product space you have Sparks inequality is there. Okay, so state and prove the Sparks inequality is there, triangle inequality is there, and also third one is a parallelogram law is there. And in the 12th unit you have Gram-Schmidt orthogonalization process is there. So state and prove, you will ask that one. So the theorems 10 marks both you will get from 11th and 12th unit. In 10th unit you will get the 5 marks questions. That is one question or based on the quadratic form they will ask. Okay, so the quadratic form means here whatever the matrix is there, if you are taking Q of like this X bar, so if it is of the form like this. Okay, so whenever you are writing matrix form in any polynomial form, that is called as a quadratic form. Okay, so that is X is here variable matrix will be there. No, if it is a 2 by 2 matrix you will get only 2 variables. If it is a 3 by 3 means you will get 3 variables. So the transpose of the variable X into the matrix, given matrix, into the whatever the given x variable is there. If you do the multiplication of these three, whatever the resultant you are getting, that is called as a q of x. That is the quadratic form. Okay. So here A is n by n symmetric matrix. Okay. And here x bar is belongs to r to the power of n. That is real numbers we have here. And r to the power of n is equals to x bar, such that x bar equals to x1, x2, so on up till xn. Okay. So where x1, x2, so on. So like this, it is the definition of the quadratic form. Okay. So if we'll take any example to solve this one, so the problem will be like this. If x bar equals to x1 and x2 and a is equals to -1, 2, 2, 4, then find q of x. Okay, the question will be like, this asked or else find the quadratic form of the given matrix. This matrix will be given and they will ask to find the quadratic form of the given matrix. So for this, what is the solution we have? That is a q of x bar is equals to x transpose of a into x. So here what is our x given in the question? It is x1, x2. That transpose of this one into matrix A, -1, 2, 2, 4. Next. Okay. So the transpose of this one is x1. Oh, what is the transpose? Transpose of means matrix means converting the rows into columns. Okay. Rows into columns is called as a matrix. Here only one column is there. If you write, then it is called as a transpose of this one. Okay. So here this is the transpose of this matrix. Then whatever the matrix is there, you multiply with this one. So here this is 2 by 2 matrix. Here 2 rows are there and only one column, that is 2 into 1. And when you see this one, here we have 2 rows and 1 column. Same one, no, that is only this one. Okay. So the condition for multiplication of 2 matrices is number of columns. Here the number of columns is 2 and here the number of rows is 2. It is satisfying the condition. So when you multiply these two, what is that? Here first row, first column, second row, whatever the column is there, only one column is there. So first row, first column and second row and first column. So when you multiply this, you will get it as -1 into x1 plus 2 into x2. Next second row, 2 into x1 plus 4 into x2. Okay. So when you have to multiply these two, here what we have, only one row is there and 2 columns are there. This is one column, this is one column. Here 2 rows are there and 1 column is there. So here number of columns is equals to number of rows for multiplication. Okay. So here we can do the multiplication as so when you multiply that one, whatever this is there, you multiply with this one, that is x1 into -x1 plus 2x1. If this is x2, -1 into x1 plus 2 into x2 plus x2 into 2x1 plus 4x2. So when you simplify this, you will get it as -x1 square plus 2x1 x2 plus 2x2 x1 plus 4x2 square. Okay. So this is the quadratic form of the given matrix. Whatever the matrix is there, this is the quadratic form of that one. So this is the answer. So if you check this one, so problems will be asked in 2 types. So first one is they will ask that one. So the matrix will be, okay. So the question they will ask, convert the given matrix into quadratic form or else the quadratic form into matrix form. Okay. So from here only you can understand, see, first one is x1 square. So first value, whatever it is there, that value is -1 here. Next we have 2x1, x2. So this value is 2x1, x2. Next we have 2x2, x1. 2x2, x1. Last, this is the 4x2 square. Okay. So if you see, the matrix form will be like this: x1 square, x1, x2. Means first row, this is the first row and second column. Next you will have x1, 3. That is this is the element of first row and third column. Next you will have x21. That means this is the second row. Sorry, this is the second row and first column. Next you will have, this is the second row, second column, and this is 2, 3. That is second row and third column. Next you will have 3, 1, third row and first column. 3, 2. Last will be 3, 2. Is whatever 2, 2 is there, you can write it as squares, or else you can put them as 3, 3 like that. Okay. So that's why, see here, whenever it is a 2 by 2 matrix, it will be in the form of x1 square, x1, x2, x21, x2 square. So whatever the quadratic form we got here, that when you write in the matrix, x1 square means 1, -1, x1, x2, 2, and this is 2, and next last one is 4. And this is for 3 by 3 matrix. So if you remember this matrix form, then from the quadratic form, you can write it in the matrix form. So the question will be asked for 5 marks, whether to write from matrix to quadratic form or from matrix to the, sorry, from the quadratic form to the matrix form. So both the questions will be asked. So if you remember this one, whatever the matrix I have written, so if you know this concept, then from the given problem, you can convert that one. Okay. So one problem we'll see on quadratic form to matrix form. See, 10x1 square minus 22 x1 x2 is there, plus 3x2 square is there. Okay. Find the, here is asking, find the matrix of the quadratic form. So this is the given problem. So whenever the quadratic form like this, it is given. What I have told, for the 2 by 2 matrix, you will have x1 square, x1, x2, and you will have x2, x1, and x2 square. So whenever like this problem, they will ask this, whatever the two values are there, these two values, these two values, and these two values, they will give as here 1, 2 here. Combination of these two values, they'll give at a time. Okay. So when you divide that value by 2, you will get the value of this one and this one, and this one and this one, and this one and this one. Okay. Here also see x1, x2 is there. But for 2 by 2 matrix, what we need, x1 square, and here x. So like this we need. Okay. So here x1 square 10 is there. Here x2 square 3 is there. But here combination of these two values he has given that one. That is minus 22 x1 x2. So when you divide that one by 2, you will get here minus 11 and minus 11. Okay. So here in the solution, you can write putting the quadratic form q of x equals to so whatever the matrix you are getting, you will get it as 10. Here when you divide this one by 2, you will get this as minus 11. Next here minus 11. So this is the matrix form of the given quadratic form. Okay. So for this only you have to find whenever 3 by 3 matrix is given. So whenever 3 by 3 matrix is given, for that one, if you find the quadratic form, for each and every element, you have to write it as quotient of that value is equals to 1 by 2 into x1, x2. Okay. So like that problem you can see here. See one example of that one. Find the matrix form of seven x1 square minus 3x2 square plus 9x3 square plus 3x1 x2 minus 5x2 x3. Okay, like this question is given, he's asking to find the matrix of the quadratic form. So if you take A is any matrix, either you can write like this x1, x2, or you can write A11, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Okay, like this matrix. If you write that or this, it is the same one. Okay, is the matrix of the given quadratic form. Okay, so from this, here x1 square is there. No, what is A11? X1 square means this is equals to 7. Next to A22 value, it is minus 3. Next to A33. So A3 x3 square, it is equals to 9. But here only 2 values are there, but we need 4 values. Okay. So here this A12 is equals to 1, 2 is there. So A12 is equals to A21 equals to, we have to write it as 1 by 2 into quotient of x1, x2. Okay, like this you have to write. A12 is equals to A21. Both are same, no? So 2 equals to 1 by 2 into quotient of x1 and x2. It is equals to 1 by 2. What is the quotient of x1 and x2? 3 is there. So you'll get the value as 3 by 2 both. Here we can't divide it with 2. Okay. So you keep like that only. Next we have A13 equals to A31 equals to 1 by 2 into quotient of x1, x3. So in the problem, x1, x3 is not there in the given question. So that value is here 0. The value is not there means both the values are 0 here. Next is A12, 21 is completed, 13, 31 is completed. Next we have 23 equals to A32. These two values, 32 and 23. So it is equals to 1 by 2 into quotient of x2, x3. So what is given in the problem? Quotient is minus 5. So 1 by 2 into minus 5 means it is minus 5 by 2. Now substitute all the values in the whatever the matrix form is there. Oh, you will get it as A is equals to, so what is A11 value? 7. Next what we have A12. So A12 value is 3 by 2. Next A13 value we are not having, so it is 0. Next A21 value. A21 value is also 3 by 2. A22 value. A22 is minus 3. Next A23. A23 value is minus 5 by 2. Next A31. So A31 value is 0. A32 value is minus 5 by 2. Next A33 value is 9. So like this, we have to write the given quadratic form into matrix form. So if you remember this one and also this concept of whatever these two values, and these two values, combination will be given in the problem. So when you split that one, you have to divide it by 2. So here we are unable to cancel out that one because here odd number is there. So we can't divide this one by 2. So you will get both the values as 3 by 2 and 3 by 2. Okay. And this is minus 5 by 2. So you put that in the matrix. So this is the method how to find the matrix of the quadratic form. And first problem is of quadratic form from the given matrix. So both you will get for the 5 marks questions, and even these directly like this problem will be given and they'll ask this one to write the matrix form for multiple choice or anywhere. Multiple choice questions will be there, no? The matrix form of the given matrix. In the multiple choice, they'll use this matrix. You have to identify this one with that one. So even you have the chance of getting this question for matrix quadratic form and also matrix form, both for the multiple choice questions. That is even in objective also you will get. Okay. So try to practice these all problems you have in your textbook. Okay. So in this only one more concept is whenever you will get like this matrix, from this we have to see whether whatever the quadratic form is there, it is a negative definite or positive definite. Okay. Negative definite and positive definite, that is also question for 5 marks one. Okay. So for this one, we have to find the characteristic equation, that is A minus lambda I of this matrix. Then you will get one polynomial. No? If for that polynomial, if you find the roots, if you are getting all positive roots, okay. So that means the lambda values are here. You think you got 1, 1, 2, or 1, 2, 3. You think. So you got all 3 as positive means then the given whatever the quadratic form is there, it is a positive definite. So if you are getting one negative and other positive, then it is called as negative definite. So the 5 marks question, they even ask on this also. So 10th unit, you will have conversion of matrix to quadratic or quadratic to matrix, or else finding the positive definite or negative definite. So for this problem only, so if you see the problems you have in page number, if you have textbooks, so page number 116 you have is the quadratic form positive definite, and after that mostly you have the problems in 1117 page number MEQ questions. So in that any quadratic form they will ask, from that you have to write the matrix form, and then you have to find what are the whether the given whatever roots are there, they are positive definite or negative definite. Okay. This is the simple one we have. So if by tomorrow we have to complete this linear algebra, next class that is on we have 25th, I think so, 25, 26. That is we have to start the electives. 3D we have to start. So tomorrow, if all of you are having the textbooks, so try to open them while class is going on. I will tell the page numbers and whatever the problem number will be there, that you take the 10 marks problems and also 5 marks problems. Or else if you are not having the test books, I will write the page number and also the problem number. So you note down in your notebook, and after getting the test books, try to practice those all theorems and also problems. Okay. So tomorrow, if you have test books, try to open them and see whatever the I am giving the important questions. Okay. So one problem today, we'll complete this one. So by this, we can complete this unit. Quadratic form a positive definite. They will ask like this question. Is the quadratic form, this is equals to a positive definite. Okay. So directly I am writing here the matrix form. So you will get here the matrix as x1 is not there, no. So 0, x2 square is there 2, x3 is also not there. So 0, here x1 and x2. If you divide it with 2, you will get here -1, here -1. Next x1, x3 means here 1. Next here 1. Next this is -1. This is -1. So you do, you follow the process, whatever before problem I have told. So try to follow that one. Directly I am writing this one. Okay. So the characteristic equation to find the characteristic equation is a minus lambda equals to 0. So this is our a, no. So a minus lambda is equals to 0 minus lambda -1, 1 -1, 2 minus lambda -1, 1 -1, 0 minus lambda. So when you find the determinant of this one, you will get the equation as it is minus lambda cube plus 2 lambda square plus 3 lambda. Okay, this when you do the determinant of this, you will get this value. So to satisfy the characteristic equation, we need this is equals to 0, implies minus lambda cube plus 2 lambda square plus 3 lambda equals to 0. If you simplify this, you will get it as minus, you take out that side. So lambda cube minus 2 lambda square minus 3 lambda equals to 0. So what is the concept to find to show that whether it is a positive definite or not? For that we need the roots of this quadratic equation. Okay. Here all values are lambda. So you can take lambda common. It is lambda square minus 2 lambda minus 3. Okay. So one we got lambda value, when you equate it to 0, lambda equals to 0. So the quadratic equation lambda square minus 2 lambda minus 3 equals to 0 means lambda square minus 3 lambda plus lambda. Okay. So we'll get the roots as so I hope so you know how to find the roots. So this is lambda into lambda plus 1 lambda minus 3 equals to 0. So the values are 0, -1, 3. Okay. So we got 3, 1 we got negative value. So it is not the positive definite, it is the indefinite. Okay. Negative definite we can tell, or it is negative definite or positive indefinite. Okay. Here, are you able to see? So you can write here. The given quadratic form is negative definite. Okay. So like this, This I hope you know how to find the simplification of the determinant. That's why. So it will take more time. That's why I have written directly the whatever the equation you are getting. So first write from the quadratic form, you write the matrix A. That matrix A, you take into the characteristic equation and you'll get one polynomial. After getting the polynomial, you equate it to 0. Here lambda is common is there. That's why we are taking common. If common is not there means by long division method, you try to find the roots of the given polynomial. If you are getting all positive, then it is called as positive definite. If you will get any one negative value, then it is called as negative definite. This is the concept of positive definite and negative definite. So like 3 different problems are there. One is the matrix form to quadratic form. Next one quadratic form to matrix form. And third one is the to show that given quadratic form is whether negative definite or positive definite. So 5 marks, 3 you will get any one. So you have even chance. I have told that even multiple choice questions, also direct multiple choice questions based on quadratic and matrix form, they will ask. Okay. So tomorrow we'll see the 11th unit. Some theorems are there. And also problems almost 11th unit are not there. Only in the 12th unit, Gram-scheme and orthogonalization process is there. No, in that you will get the 10 marks problems. Whether they may ask the theorem or they will ask the problems on that one. Okay. So tomorrow we'll see. Okay. Bye, students. If you have any doubts, you can ask me tomorrow.